Hey there, I'm Ram. This is Ramj. I'm going to be building a multi-label classifier using Fastai and Unsplash images. So this is deployed in Heroku, and this version that you are seeing right now is training in 100 labels. We can we can load a random image from Unsplash. Waiting. Another one, maybe. Or we can select an image. Okay, we're going to use Colab for training the model. So first we're going to set up the Fastai AI library. We're going to import the vision class of Fastai AI. We're going to use request to fetch the images. Then if you want to save the URLs to Drive, we need to mount Drive to Colab. Okay, so here we're going to have our labels, and I'm going to show you how to fetch them in a moment. Okay, so I have a version of this that have 100 labels, but I'm going to have a small version here to do this faster. This script here breaks this string into pieces and separates the different multilabels with a comma. Okay, don't forget to put your load time in GPU because we're going to need that. Here you see that the different labels are separated by space. You can add more than 3, you can add a bunch of them, and then the script is going to separate them by a comma. This is the list of the labels. So okay, this is how we're going to get the URLs. We're going to start from calling this function that is going to accept a list of labels, the number of uh, the quantity of each label, and a path where we're going to download CSV files from each label. This function here takes the targets, the amount of targets, and the path, and from every target it calls a multi-threading function that calls thread pool execution with the function get URL, and we pass it. Here's a little thing that we need to do, because if we have multiple requests to Unsplash, but we don't differentiate each by some number, the cache of the request is going to give us the same URL. So we need to pass a number to this variable here, for the URL to be different. So this right here is going to contain the target, the label target, and integer. Then this function right here downloads the target labels to a file, to a CSV file. Okay, and I think we are ready to get the files. We store in this variable all the labels, and yeah. Okay, so the process have finished, and we can see all the CSV files that it creates. Okay, we're going to use the download images that is part of the Fastai to download the files. We're going to download them in the DS folder, and we're going to create a folder for each label. Later, we're going to see that we're going to use the name of the folder to label the images, and we're going to use a custom function to do that because we have multi-label for each image. Right. Basically, what it does is it creates a list with all the images. Then we have here the constant function to extract the labels. I show you. So for example, this function does this. It grabs the path of the file and it gives a list of the IDs based on name of the folder. Alright, so we're going to use image data bunch to create the data bunch. We're going to use the method from name function, and this method is going to accept a path, that is the path of our file name path, that is the list of file names that we create here. The label function that it labels every file, every image using the name of the folder that is in, the percent of the valid dataset. This is standard transfers that it does to the images. The size of the image in this example is 500. If you want to change this, you need to change this size here from the original file, and then change this to whatever you want. That's it. This is an important variable because if you have problems with memory, you need to decrease this, and if you don't, you can increase it, and maybe you go a little bit faster. Then we normalize to ImageNet stats because we're going to use transfer learning when we train the model, okay? We can do data.classes to see if all goes well. We can go and see to a batch. As you can see, we have animal horse, tree, dolphins in water. This is not a dolphin, but whatever. Right here we have horse. Alright, we're going to train. Okay, so we're going to create here a CNN learner based on our data bunch here. We need to pass it that. We're going to use the ResNet 34, as you can see there, and the metric accuracy threshold because we are doing a multi-label problem here, and we can't use the standard accuracy. Okay, this is downloading the ResNet. That's done. We're going to first find the learning rate that is optimal for our program. The learning find has finished, so we have around 2 right about here. So we have 2 and 3 and 2. This is optional, but if you are doing this and you are doing a lot of training, you need to save the model in each iteration. So for that, you use a callback. You use the same model callback, and we're going to save the learn using the monitor accuracy threshold. That is what we are using from the metric. The max model is that it's going to always save the maximum state of the model, and this is a name. You can have whatever you want here. So as you can see, we have 90% accuracy threshold, and now we're going to save the learner. Keep in mind that this is going to save around here models. The model is going to save here, but also we have the class base here. So if you want to keep that, you need to download it or change the path to your Google Drive path to automatically save it there. Okay. Now we're going to unfreeze the learner. This training that we did here was the last layers of the model. Now we're going to unfreeze it, train it a little bit more, and we're going to see first what learning rate we should use. So in this stage, we're going to fit the model, but we're going to do it very, very slightly because we're training the whole model, and we don't need much learning. So this has finished. Now we're going to look at how the model performs. We're going to call this class here to give us a lot of interpretation methods to try, and we're going to plot the top losses. Okay, let's see. The model predicted waves, and this has wave, but the actual was ocean and water. Yeah, now break the city, but this was labeled animal house. That is not good. Okay, yeah. Now we're going to predict a custom image. Okay, so this function it gets an image from Unsplash and it saves it to a path. We're going to change this because here is code. Okay, and then it returns the image. Okay, this function here is not that important. We're going to see that in the next video. We get the image, we show it, because yeah. Going to select this for later. Show this. Okay. For example, we get an image, this one, and we called learn not predict, and we pass the image. We see that buildings have 55%, and that's not right. We can have another image if we execute that again, and we need to execute this again, and the probability is going to change. Now it detects water 99% because there is water here. In the next video, I'm going to show you how you can deploy this model to Heroku, and I'm going to show you how you can do this. If you this is really similar to this, because in the backend of our app, I'm going to use exactly this function to return the top 5, and that is the thing that you are seeing right now. So nice, we have trained a model to classify images. In the tutorial we have 20 labels, but what you see right here is 100 labels that I classify. It takes a little while to do that, so I only did 20. You can, though, if you want, do whatever amount you like. Right here, as you can see, we have 21. If you right here, pick a comma and space, separating the labels from each request, you can have that. And yeah, in the next video, I'm going to show you how to deploy this Heroku app, and we're going to use React and Flask to do that. So yeah, stay tuned, subscribe if you want to see that. I see you in the next.